Towards the front is, going away from me, is the pneumatic relay board. That allows you to drive up to 8 channels of 12 volts at 1 amp apiece. And that is designed specifically to replace spikes driving your solenoids for your pneumatic system. So the idea being we're trying to make things a little bit more compact, a little bit lower cost. We will continue to support spikes. In particular, you'll need a spike, obviously, to drive the air compressor for your system. The motor controllers you see on there currently are Victors, the 884s, the tried and true tested 884s. We also have a smart motor controller coming. I can't tell you the name of the company, and I can tell you a few things about it, but I won't give you the details of the company. That's coming soon. This particular motor controller is a smart motor controller. For 2009, it will do PWM control, just like the Victors. In 2010, we're going to be adding CAN bus connection to it, so you'll be able to talk to your motor controller. You'll be able to get things like temperature, current, voltage readings, status, and a bunch of other things that you'll find out about soon enough. It's not going to be called a smart motor controller because it's dumb. There's an awful lot of power underneath that hood. There's a Cortex M3 microcontroller underneath the hood. So when you go home, do a quick web search for Cortex M3. And that'll give you an idea of the power that's going to be inside that smart motor controller. It's going to open up a lot of possibilities. Probably make the game design committee think about a couple of things. That's going to be interesting to see what they can do. Just to give you all an idea, if you have a smart motor controller, what do you think some of the things that you could do with a smart motor controller? Anybody have an idea? PID loops for feedback. Absolutely. Absolutely. Instead of using the mainline processor to control the motion of your arm or the speed of your wheels or the distance your wheels drive, you'll be able to tell the smart motor controller, go this far, or go this fast, or go this far until you hit the limit switch. And the smart motor controller will shut itself down because it'll be able to monitor a number of its inputs and say, oh, I'm where I need to be. And then it can interrupt and tell your main processor, hey, we're done, next step. So we're going to try to spread out some of that control, give you a little more power, a little more flexibility, and at the same time, try to make it as easy as possible this first year, which is why we're sticking with PWM. One of the nice features that's somewhat underappreciated is the power distribution board, which is situated between the Victors. The power distribution board connects up to your 120 amp circuit breaker off of your battery. And the power distribution board does a couple of things. It provides the power and ground connections for all of the circuits for the rest of the robot. And the second main function that it does is it provides filtered power to the C-RIO, the wireless unit, and your camera. The idea being we're eliminating backup batteries, so there's going to be no more backup batteries necessary. That's going to be a lot nicer, yeah. How many times have you tried to run with a dead backup battery? Not pretty, right. We're trying to avoid that going forward. One of the questions that I do get asked quite a lot is, are the cold cathode lights coming in the kit of parts? No. Or maybe. I don't do kit of parts. That's not something I can talk about. You have got cold cathodes before. Does anybody know when you've got cold cathodes? Yeah, the green lights for the targets. It's the same technology. They come in a lot of different colors, we found. It's actually very cool. So it's a nice decoration, I think. So yeah, we're letting some teams drive. So if you want to come down and take a chance to drive around a little bit, get a little feel for it. This is a very simple setup. Smokey, I'll warn you, is center wheel drive. He's not the easiest beast to drive. He spins real well. He's very maneuverable, but at the same time, it takes a finer touch. Next generation Smokey, Smokey 2. We're going to put sensors on him so we can say drive straight. Just keeping an eye on this guy here. You'll notice there's no bumpers on this, right? Yeah, me too. I'm noticing. This is one of the 6 robots that we're using back at first in the first floor field for testing purposes. The wireless unit that we have on there is a gaming wireless unit. It's one of about 4 others that we're using for testing purposes right now. So this is an example of one type of wireless unit that we're looking at using to drive. Speaking of wireless, we're going to be 802.11n. We were using 802.11a at Championship, and based on some feedback from some consultants in the wireless field, they suggested we go to N because it's going to be the future bandwidth, the future technology to be in, and that's where we wanted to be. We wanted to be in the future. We chose N or A originally for the same reason. There are 11 free channels up in the 5 gigahertz band. The idea being we'll be able to run all of the fields at Championship at the same time without anybody interfering with anybody else, which we're really looking forward to. The other option that we're looking at is because of the way we're doing wireless, the wireless is set up with IP addresses on the robot and the driver station so that that's how we communicate. It's just like right now on the internet when you talk to a wireless IP somewhere else, wired or otherwise, you're just sending information to an address. Now, if you think about that for a minute, if all the robots have addresses, the robots can talk to each other on the field, can't they? Think about what the game design committee will do with that. And I'm smiling because I haven't told them that yet. So yeah, it's going to be very interesting. There's going to be a lot of future upgrades and a lot of future potential coming on board. The other nice part about the wireless is there's a lot more bandwidth. Whereas our current system ran at 9600 baud and had very small packets of information, right now this guy runs at about 11 megabits per second. So that's a little bit faster. We're also sending 1 kbyte. That's 1,000 bytes roughly of information for status from the robot back to the driver station. The driver station has a couple of nice features. It has 4 USB ports for USB-based joysticks. Each of those joysticks will support 6-axis as well as 12 switches. So I would like to see a team use all 6 axes on all 4 joysticks and all 12 switches on all 4 joysticks. Plus, the other addition are 8 digital inputs, 8 digital outputs, and 4 analog input pins on the driver station so that you guys can create all your custom interfaces that you like. So we're trying to put in an awful lot there for you to be able to play with and to be able to grow. The nice feature about the driver station is the LCD display. The LCD display is a graphics display that's going to have menus with select and scroll buttons so you can select menus and scroll down and look at things like your joystick information. What are your joysticks saying? Or you can look at the robot status pack. It's coming back and saying, what's the robot telling me? The other nice feature is a second Ethernet port that you'll be using to connect up to your PC or laptop so that you'll be able to wirelessly update your program on the robot. So you won't have to have that tethered programming cable when you're home. There is the tethered option for use in pits, and that's just a basic Ethernet connection. So you use a basic Ethernet cable. One of the things we are looking at, and it's a bandwidth issue, and we're trying to understand what the real constraints are, but what we want to do is take that camera that you see on top of the robot and transmit images back to the driver station. And what do you think we could do with that for a game? So we're looking at what the bandwidth is, what the constraints are, and whether or not it's going to impact the drivability of the robot with all that additional information. But it is certainly something that we're looking at and certainly something that's technically possible. So as you can see, it's pretty responsive. I will say, back at first, we had 6 robots running around off the same low-end D-Link access point wireless router, all 6 channels going through one router on one channel, and the responsiveness was incredible. We didn't see any lag, any lead at all. It was very nice. It worked very well. So we continue to test. It's principally what I'm doing now is testing and final integration, and we're working on, as I think you all heard yesterday, the announcement for the beta team testing. Those will ship September 15th is our target to ship. So please make sure your team gets in its application if you're interested. A little background behind the beta team testing. First is looking for teams to really wring this thing out. I want this to be tested. I want teams to have an understanding of what it can do. I want you all to understand how to use this. And with the beta teams, it's going to allow us to spread some more of the knowledge that we have currently just at first out to the rest of the field. The other thing the beta team testing is going to do is help us get all our documentation, all of our training, and all of our bugs worked out so that you guys will have a finished, fit, and polished system. Now the question that most people ask that I don't have a clear answer to yet, and that is, when am I going to get my new control system? Does anybody not want to know that? The reality is we are working on an early release. I do not have the final date. I'm waiting for commitment from all of our manufacturing to make sure that I have all of the units in place so I can ship all of the kit out to the teams. We expect to have everything in-house sometime in October. Right now, I don't know if it's October 1st or 31st. As soon as we get firm commitments as to our deliveries, we'll be releasing an email telling teams when they can expect their early shipment of the new control system. And that's about as close as I can get for a date. I would like it out by November at the latest, and that's our target, but we don't know because I have not yet gotten commitment from all of our manufacturing. And as soon as that happens, we're going to pull the plug. So I've been around yesterday, and I'll be around for a while today. I'm over by the practice field in that far corner, and if you have questions, come on by. Thanks.